Example number 1. Now remember, we also mentioned in the previous video the difference between an exact value and an approximate. The exact value meaning leaving it exactly as is, not approximating with a calculator or symbols like pi. So when they ask us to find the sine of -3 pi, they don't want you to use a calculator. All right? So how do I find the sine of -3 pi? What did I tell you often helps? Give yourself a quick sketch. So draw that circle out and figure out where you're going to be when you do -3 pi's. And remember, I also told you all to memorize pi radians is equal to how many degrees? Hopefully you said 180. Now don't lose the negative, but we are going to have to rotate -1, 2, 3 pi to get to this point right here. Which, if they didn't specify how big of a circle we have, then what does that mean? What would we choose if we had one choice? That's right, a unit circle of 1. So this value right here would be -1, 0, meaning my radius is also 1. And if I'm asked to find sine on the unit circle, I know it's equal to always y over r, but on the unit circle, just y. So all I really need to know is my y value, and because we're at -3 pi, which they made us go around one full circle by saying 1 pi, 2 pi, right where we started, and then a third pi negatively, we would be at this point, which means our y value is neither up or down any, so our answer is 0. All right? So the cool thing is you don't have to recreate the wheel, no pun intended, for the circle. Just use that value, use that point, and see if you can find cosine and then cotangent for me. Go ahead and pause it here, give that a shot, and then I'll do a quick explanation of what you should have gotten and why. All right, I just copied it down and pasted it 2 other places for you to see we're dealing with the same angle in radian measurement. The pi gave it away that that was the case. And cosine we know is x over r. Since our r is 1, we're really just looking for the x value, which they told us is -1. So there's our answer. Hopefully you got that, because then if you do, cotangent, hopefully you know also is cosine of an angle over sine of an angle. Because remember, it's the reciprocal function of tangent. And since we have both of those things, we can just put -1 divided by 0, which means therefore our answer is undefined. Again, if you just did it from scratch and you didn't see that you had this yet, that's okay. You should have known that cotangent is x over y. And since we have the x value and we have the y value, then you could have gotten that undefined either way. All right? Pretty simple. Keep working on it. Just a little different look in the fact that we're always going to be on the unit circle unless they specify the radius or other values to find that radius that are different. So the second example here, I wanted you all to just pause and try on your own because it's virtually the same type, but notice they are definitely evaluated for these trig functions in terms of radians. And once more, they want your answer in exact values, not punch it in your calculator and letting it do all this thinking for you. All right, so go ahead and pause it, give that one a try. If not, come back and I'll explain it, at least part A, so that you can then try part B. All right, if you gave that a try, good job. Hopefully you got the right answer. Remember, one of the nicest things about radian angle measurements compared to degree angle measurements is that even though you have to find the reference angle, what quadrant you're in and all of that for both to see whether they're positive or negative and what the value is, with radian measurements, it already tells you that this is a 60-degree angle as your reference. And since I know that the sine of a 60-degree angle which is our pi over 3, is equal to what? Hopefully you said root 3 over 2. I'm done. All I have to figure out is whether or not it's positive or negative. And that's where this 4 is going to come into play, because I actually have this 4 times. So what is 4 times 60? 240. And where is 240 located? Well, that would be 180 plus how much more? That's right, 60 more. And that's why I really, really like radian measurement angles better than degree, because it already tells me what my reference angle is. All I then have to figure out is whether it's positive or negative. And because they put me at this point in quadrant 3, I know it's negative and I'm done. Hopefully you're picking up speed. If you want to pause it, go ahead and try the second one. By all means do, but there's not a whole lot to do, because we know, because we are in this quadrant still, but this time with cosine, it is also going to be negative. But because it's that 60-degree reference angle, I know that the cosine of 60 is equivalent to the sine of 30, which is 1/2. That's it. If you want to memorize it via the unit circle, that's fine too. You would have just written this as negative 1/2 comma negative root 3 over 2. Okay? However you get there, just try to get there as quickly as possible so that we can keep adding on more things and you guys memorize these. So do me a favor, pause it here if you didn't on part A and try those, which are different angles this time. All right, I'm going to start this first one off by doing the tangent of negative 9 pi over 4, which is one of my all-time favorites. Not the negative, but the pi over 4. Because I know pi over 4 is equivalent to 45 degrees, and I know the tangent of 45 degrees, or pi over 4, is equal to 1. I just need to figure out what quadrant negative 9 of those is going to put me in. And if you recognize that negative 9 pi over 4 is an extra 2 pi, if I do 8 pi over 4, that's 2 pi. I know that I'm really going to just go an extra pi over 4 to give myself 9 pi over 4s. And of course, they're all going to be negative in order to keep it a negative 9. So I'm not going to waste my time going all the way around this thing. 1, 2, 3, 4, 5, 6, 7, 8 pi over 4s, because that just gets me right back to my starting place. I'm just going to go back a pi over 4 to get there. And because I know that all students take calculus, and I know that this would be a 45 or pi over 4 angle, then because tangent of that is equal to 1, I know my answer is 1, but because it's here, it's going to be a negative 1 as my final answer. All right? Sine of pi over 6, let's see how fast you can do it. Notice that is almost 2 pi. 12 pi over 6s would be exactly 2 pi. We have 1 less. So that means I'm just going to come back a pi over 6, or 30-degree angle. Which means, again, I should have known immediately that pi over 6, which is equal to 30 degrees, is my reference angle, or reference arc, they're calling it in this section. And since I know the sine of 30 is equal to 1/2, I know that is my answer. It just may be positive or negative. And because we're dealing in this quadrant 4 here, for this 11 pi over 6s, then I know it's going to be, because it's sine, negative 1/2. Hopefully this is really clicking and you're getting excited because you understand things, and it's actually getting a little bit easier because we're doing a lot of the same stuff. So it's just practice, 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 so that you see all these different reference angles or arcs over and over and over, and it gets more and more simple to evaluate. All right, looking at example 3 here, you can see it definitely asks us for a little bit different value. Now it wants us to approximate these quote-unquote circular functions. So there's our hint that we're going to have to use a calculator because it says approximate. So when you see this, the sine of 3.42, you guys all have to know when they write any trig function, you have to write something after it. Otherwise, that's a sin. Okay, you have to have something following it, and it has to be an angle. Whether they write the angle in radians, as they've done here, or they write it in degrees. You have to know that what is following each and every one of these trig functions is an angle, theta, or the arc, S. So if you're going to evaluate this into your calculator, you first off have to make sure that it is in radian measurement. So go ahead and pause it here, see if you can find your calculator to convert it to radians from what it was in degrees, and then evaluate these, and I'll give you the answer for each. Let's just do the first two, A and B, and then part C and D a little bit more difficult because they're not one of our big three trig functions, and I'll go over those in more depth. Now don't forget to read the directions because they're also going to ask you to find to the nearest 10th, 100,000th, or 4th decimal place, whatever. In this case, they did want us to take it to the 4th decimal place, so that's what we want. We got to look here to see what we're going to do. So we're going to say the answer to the first one is negative 2.748. That would be the ratio approximately about 1/4, a little bit more than that, or 0.2748 for the sine of 3.42 radians. Okay, so make sure that you've changed over to radians if that's what they've given you. Go ahead and try part B on your own now if you had on part A. And you should have gotten 1.0790, again rounding to the nearest 4th decimal place. Okay, but for the next two, they're a little bit different in the fact that they gave us secant. And we don't have that button on our calculator, whether it's degrees or radians. So that means we have to change it. And if you remember, the secant of any angle was equal to 1 over cosine of that same angle. So that's the only switch that you have to make. This, you're going to have to put 1 over, or divided by, the cosine of 5.6041. And that will give you 1.2851. All right, so go ahead and try part D if you haven't, but these are the ones I actually worry about the most because of the calculator and people just making mistakes without actually knowing that this is the correct answer or this is the correct answer versus anything else that you just plug into your calculator and not really having a feel. So this next example 4, I'm going to show you how you can kind of get a feel and know whether your answer makes a little bit of sense or not. But before, try part D. Cosecant theta we know is equivalent to 1 over sine of that angle, theta, or arc in this case. So we're going to put 1 over, for this, the sine of negative 2.7335. And if we evaluate that, we should have gotten negative 2.5198. So if you're struggling with those, please get help. Come see me or our tutor, or go to the tutorial center and make sure that somebody kind of walks you through on how to punch these into your calculator. Don't stress too much. We're not going to have a ton of these for obvious reasons. I don't like them, but we do have to have this on our repertoire and our tool belt in case we ever have an issue where it's not a nice reference angle. All right? On to our 4th example, which now tells us, as I mentioned, without using a calculator and just your knowledge, can you tell me whether the sine of -1 or the tangent of 4 are going to be positive or negative values when we evaluate these? So as I mentioned previously, what is this -1? And what is this for? What do they represent? What has to follow a trig function always? It has to be an angle. And if the angle is not written with that little round symbol we call the degrees, then that means it's in radians. So make sure that you know that this represents -1 radian, 4 radians. And if you remember also, I derived what 1 radian was about. And remember, it came out to about 57, but we said that's even easier to just round up and say 60. Because remember, we said pi is equal to 180 degrees. And if I wanted to know the left side, which represents our radians, then I'd have to divide both sides by pi. And that would cancel out to give me 1 radian. And if I wanted to approximate this, I could punch in what this is about. Okay, I'm done impressing you. Punch that in your calculator and you've got about that 57, but that's too much to do and memorize. We like to be able to do things in our head and not rely on tech. So we said we'll just use about 3. And 3 goes into 18, 6, and 0, 0 times. So we said that that was approximately what we would be going for each and every radian measurement. So if we're asked to find whether things are positive or negative, all we have to do is figure out what quadrant we're in for each of these. And because this first one here is a -1, that means we're simply just going to go back about 57 or 60 degrees. So we're in this quadrant, which means since we're dealing with sine, this would be what? Some negative output value, like we saw in the previous example. Some nasty old long decimal or whatever. So see if you can do part B real quick, just by pausing, thinking it through in your head. What angle measurement would that be about? And we know that 1 radian is equivalent to about 60, so 4 times 60 is about 240. So since that is 270 around, and this is 180, we know we're somewhere in here. Doesn't have to be exact, it's just in this quadrant, which means since it is tangent, we would have been positive if you did actually punch that in your calculator to check. All right? Pretty simple, but this is a way to try to make sense of some of those other values. And we'll hopefully make it make even more sense when we go on to the next chapter and start graphing these things. Okay? So let's try one more type, and that's working in reverse. And remember the fancy word that we use for reverse in math? It's called inverse. And so 2 different types here, one that's going to ask us to approximate, one that's going to ask us to find the exact value. And then they're even telling us where that value of S or that arc length is. For this one, between 0 and pi over 2, meaning we are in quadrant what? 1. And then this time, instead, since they're asking us for the angle measurement per sine, then they're going to have to give us the ratio. Now notice that ratio is definitely not something that we know. It's really close to 1/3, but remember we never had a 1/3 for any of our 45s or 30s or 60s. Those reference angles, or arcs in this case. And how do we know what they want the answer out as? A degree angle measurement. Usually they'll use the symbol that really looks like a degree. If they want it as a real number, a radian, then they'll either use X or, for now, S. Right? So when we're dealing with these, make sure that you also use what was given. They told us between 0 and pi over 2. So we definitely know that we're in quadrant 1 and in terms of radians. So how are we going to do this? Well, if they want us to approximate, we know we're probably using a calculator. And if I want S by itself, remember we can't just divide by a trig function like sine. So I'm going to have to take the input and the output and reverse their order. So I'm going to put the sine of 0.3210 would then be equal to s. But remember, I just got done saying that we cannot have anything but an angle following sine. And now I just switched our angle and the ratio out. So I have to make sure that they know, the calculator or whoever is looking at this, that this is no longer an angle. It's the ratio that we got out. And that's by putting that -1 power above the sign. That, remember, is our symbol for inverse. And because that can be a little bit tricky, we will also even say arc sine. And that is also a way to write the inverse, to find that angle. All right, so go ahead and punch that in your calculator and make sure that you get out the angle for S that we're looking for the inverse or arc sine of 0.3210. 0.3268, which remember is the approximate angle measurement on that unit circle in radians. So very different. If you actually look at this, which was the ratio that we got out, and this, which is the angle, the arc length, they are almost identical. Okay, so I did this first example just to show you that this can be very confusing and you don't really feel confident in your answer because does that look like the right answer? I don't really know. It looks a lot like what I originally had as my problem. So be very careful with it. That's actually why I don't like the approximate calculator ones nearly as much as the exact values, because if they want us to find the exact values, that means they have to give us something nice. Something that we know, like a reference angle. So this time, what quadrant are we in? I'm going to draw that. Three pi over 2 and 2 pi is the interval that they gave us to work behind or between. And 3 pi over 2 and 2 pi means, remember, 1 pi over 2, 2 pi over 2, which is just pi, 3 pi over 2s, and then 4 pi over 2, which is 2 pi. So I know I'm between here and here in quadrant 4. And so do I know whether it's going to be a positive or negative? Well, they did tell me that it was going to be negative, so we could have ruled that out right away, right? Because we're dealing with tangent and it's negative. We know, therefore, that it cannot be a positive, but they told us don't play in quadrant 2, go to quadrant 4. And so all we have to figure out is what angle for tangent gives us √3/3. And if you have all these memorized, you know that because it has the √3 involved, that's in the 30, 60, 90. And remember, the 30 is much less than the 60, so that would be the 30-degree angle there because of the √3/3. So we know that we're dealing with a 30-degree what, though? Reference angle or arc. So that means because it's in radian measurement, I'm going to change that 30-degree to its equivalent, which would be pi over what? 6. Hopefully you see this. My 180 up top, if I divide it by what number would I get the 3 and then the 0? That would have to be a 6 to get the 3 and then the 0. Remember, because pi is equal to 180. So it's pi over 6. And I want just that reference angle of pi over 6. So I don't want to go all the way around. I want to come back just that pi over 6. Which for us, since I know 2 pi is what we're dealing with going all the way around, and I want it to be over 6 as my reference angle, I'm going to multiply by that to get 2 pi is equal to 12 pi over 6. There's my 2 pi. But remember, we said we wanted to come back a pi over 6. So I will subtract off a pi over 6 to get 11 pi over 6 as our answer. And again, that is what is called an exact value. Okay? So hopefully that made sense. If you need to do some more in practice, I highly suggest you start in on the homework right away. And then that way, if you're still struggling with some, you can hit similar example and do another one just for extra practice. All right? If you need help, discussion boards, reach out to any of the tutoring sessions or come by any of mine and we'll iron all those kinks out for you so that you can really get down to business. All right? You guys have a good one. It's been real. I'll see you at the next one.